Right. So what is this? Quantum mechanics. So here we are going to start this first paper, that is quantum mechanics. What is quantum mechanics? So before going to start this quantum mechanics, first of all, please tell me any mechanics, what it will do. What is the main aim of mechanics? Or at least what is the main aim of physics? To study the behavior of the system under some circumstances. Am I right? Okay. So one second. Now if you consider this mechanics. So here what we are going to study? We are going to study the behavior of a system. Which system I didn't mention? Just wait. A system under certain conditions. Okay, fine. So we have already one mechanics. From the school level onwards we are studying. Our hero, only one name we are hearing from the school level. What is that? Newton. Yeah. So let me take this classical mechanics. Okay. So what is this classical mechanics? Study of behavior of which system? Macroscopic system. Good. So this is nothing but study of behavior of macroscopic system. Wait a minute. Macroscopic system. Okay, fine. Now let us consider this one. Okay. So now here this is the mass m which is falling down. Alright. Are you observing? Right. Now I want to study this motion. Whenever you are studying the motion of any body in mechanics, especially classical mechanics, the first thing what you have to know, hello, see the board. First thing what you have to observe, under what force it is moving. Say yes or no? Yes. Because the motion of the body under certain conditions. Here the body is moving under what condition? Gravitational force. Instead of this, I have taken a charged particle, an electron, proton, something like that. Okay. Then what I will do? I will apply some potential. Then what is the force acting on that? I will say some electric force is acting. So whenever you want to study the dynamics of the system, the very first thing what you have to observe is force. Right? Now this is the motion. Could you please tell me what is the force here? Gravitational force. Okay. Wait a minute. Now I am taking a small task. Now here is a body of mass m. Observe carefully. This is the body of mass m and this is the ground, let us suppose. Now this is a freely falling and initial velocity u equal to how much? 0. And it is moving under gravity. That's why that gravity is always downward. Okay, good. And after that, could you please tell me what is the equation here? F bar equal to dp by dt. Rate of change of momentum is nothing but the force. This is the Newton's laws of motion. Am I right? This is nothing but m dv by dt. Sir, why you have taken mass as a constant? Don't write. Please see the board. Don't write. Babu, don't write. Please see the board. Why you have written mass outside? Constant. Under some circumstances. That means under some conditions. So here you have taken a condition of what? Mass is a constant. Can you please tell me in which case mass is a variable? Relativistic case. So if I am treating a relativistic case, I cannot write mass outside. Mass is keep on changing. Okay, mass is a variable there. Okay, fine. Now let's come back. F equal to m into dv by dt. This is nothing but mass into acceleration. You know that? A bar equal to simply F bar by M. And we can derive some formula from school level we have seen. V equal to U plus AT, and the second one S equal to UT plus half AT square. Everybody know this. I can write this as the displacement or distance after some time t. I used two words. I said R. I said a distance or displacement. Shall I use that word here? I can't use distance. I can't use distance. What is this? Distance or displacement? Both are same. Whenever you are moving in a straight line path, distance and displacements are same. Bird motion, distance or displacement? Displacement. Aeroplane? Displacement. Aeroplane, bird never travel with a distance. That is a displacement. Bus? Definitely distance. Definitely a distance. Air distance is the displacement. Bird, airplane, everything is the displacement. Okay, right. I can use the word distance or displacement because this is the straight line motion. So I can say this is the distance after some time t. So I can say ut as the initial one, x of 0 plus half. Acceleration is nothing but what? F by m into t square. So listen, see the board. So finally, to describe the motion, here we have an equation. What is that? X of t equal to x of 0 plus a half f by m into t square. That's good. Okay. Again, I am going to conduct the experiment. The same thing. So this is the mass and it's falling down. By using this equation, you are going to find its position after every interval of time. Say yes or no? Yes. After 2 seconds, after 3 seconds, after 5 seconds, you can find the position of the body. Say yes or no? Yes. Here is a problem. What problem? How you are observing. How you are observing. You didn't understand the question, I think. Now let us suppose the same experiment I am conducting and you are studying the motion of the body. Let us say it's a night time, let us say. Lights off. Okay, no sunlight, no artificial light. Again I am doing the experiment. I will get the experimental result. Can you observe? No. Carefully understand. Then if you understand this 15-20 minutes discussion, you will understand what is the difference between classical and quantum. I think the first task is clear to everyone. Is there any doubt here? No. Good. So by using this equation, we are going to find the position of the body after any interval of time. Now I ask a question. How you are observing this? For example, all the lights off, there is no sunlight, that means it's a night, completely midnight. So I am doing that experiment. Can you see the motion? Can you observe the motion of this body? No. Now tell me, how you are observing? Huh? Radium. Medium. How you are observing this? Yes. Now for example, now I am doing an experiment because you are observing the study of the motion. You are observing the behavior of the system. That means you are studying. Let us suppose the mass is falling down, and how you are observing means first you are focusing some light on this and the light is reflected to the retina and then you are observing. Say yes or no? Yes. Then why didn't you consider the light effect on this? Any quantity representing the light effect? No. But still without light you can't observe. Say yes or no? Yes. So finally what you are saying is, yeah, this this is the body of mass m which is falling down. But how you are observing means the simple common sense. The light is falling on this. This is the light, no doubt. And again it is reflected and you are observing. But in this motion, that means whatever you have discussed for the last 10 minutes, you have not considered the effect of radiation probe. Radiation probe. Probe means something hitting. Probing particle. Probing particle means something is going to hit. For example, if I throw a piece of chalk on you, that is nothing but what? A probe. So here completely we neglected the effect of radiation probe, or completely we neglected the effect of radiation. Are you understanding? Yes, so that means here the light falls on the object, light falls on the object or body and reflected. But in this macroscopic study, what we have done? We have neglected the effect of radiation probe. The effect of radiation probe. Why? Because it is a macroscopic world. For a macroscopic system, you need not to worry about the radiation probe. Are you understanding? So here we have considered only one effect. What is that? Gravitational effect. Whether you consider this light effect or not, it does not matter. Whether you switch off the light or whether you switch on the light, it travels the same distance after 2 seconds. It travels the same distance after 5 seconds. Are you understanding? Yes, if the light's on, then it travels 3 meters. If light's off, it travels 1 meter. Isn't it like that? Yes. So that means what? For a macroscopic motion, or for the motion of a macroscopic body, the radiation effect is completely neglected. This is what Newtonian mechanics or classical mechanics. Okay. Now let us do this. Now let us reduce the size of this. Let us reduce the size of the object to angstroms, towards 1 angstrom, like that. 1 angstrom means, shall I take it as an atom? Yes. Now again the atom is moving, or atom is falling, or atom is moving. Now can I neglect this light effect now? Why? Microscopic world. So whenever you are coming from a macroscopic to microscopic world, your Newtonian mechanics is completely failed. The Newtonian mechanics or classical mechanics could not explain any phenomena in microscopic level or microscopic world. So we need to construct a new mechanics which can explain the phenomenon in microscopic world. That mechanics is nothing but what? Quantum. In this first class, we will explain how this quantum mechanics was built and what is the basic idea behind this quantum mechanics. We will discuss. Okay, I hope you understand. The Newtonian mechanics is applicable only to macroscopic world. Light observation is there. That means light is falling on the object, but still that effect is completely neglected. Is that clear? Come on, write down. If any doubt, please ask. Don't write during the explanation. Once the explanation is over, we'll give some time, then only please write. Yes?
What is the basic difference between distance and displacement?
Distance is the distance traveled by a body. Displacement is the shortest distance. Displacement is the shortest distance. See here. For example, now this is the point A. Okay, so For example, let us say this is the point A. See Babu, you are going like this. This is your destination and this is your starting point. So let us say this is a B and let us say this is a C. AB plus BC is called a distance and the shortest distance is called a displacement. This is the displacement and this is the distance. Shortest distance is called a displacement. That's it. Sorry?
So the definition is x of t is equal to x of 0. Why you put 0 at there?
That is the initial distance at a time t equal to 0. What is u into t? U is the initial speed. See, don't ask school level questions. Velocity into time is what? What is this? Velocity into time is what? U is what? Initial velocity. Then what is this? Initial displacement.
In macroscopic system,
Stand and ask.
in macroscopic system, light is falling on the particle.
Yes.
So maybe some light energy will be absorbed and some will be reflected. So some energy is absorbed by the particle. So that energy will be so minimum that it does not affect the total energy of the.
Newton's laws of motion won't be affected by that light.
So then
That's
that
neglected.
energy will be very less.
Less. Or actually this Newtonian mechanics domain, that is the whatever we are discussing, the classical domain, okay, that light effect is negligible for this domain. Something will be there but it is negligible. So for example, if you consider the elementary particles, okay, so two elementary particles are interacting. What interaction will be there? Strong interaction, electromagnetic interaction and weak interaction. But one more will be there. What is that? Gravitational interaction. But it is neglected because of it is a microscopic world. So for a microscopic world we are neglecting this gravitational effect. For a macroscopic world we are neglecting that light effect like that. Because it won't change much. There will be no drastic changes. That's why we are not considering that. No rough notebooks. If you bring tomorrow also, you will go out along with the notebook. Don't bring rough notebooks. I'll give sufficient time. Please listen carefully and ask the doubt, but don't ask very small school level doubts, please. Please ask at your level. Because if I am explaining these things, how many years it takes? Intermediate 2 years, BSc 3 years, M.Sc 2 years, total 7 years you have to stay. That's why we have given a bridge course. The people who are asking those basics means you didn't attend the bridge course. Right. Ready? Is it completed? Ma, don't write like that. Don't write in the two parts. Right. Now ready. So here I am considering the microscopic system. Microscopic system. Listen. Please listen. Now here earlier I have taken this one and it is a falling under gravity and the equation is very simple, F equal to ma, and you got x of t equal to x of 0 into x of 0 plus half AT square. A is nothing but F by M, where F is the gravitational force. What is the gravitational force? mg. Okay, I hope everybody know. Good. Okay, so now what I am doing is, I am taking the body again, but this size is of order of 1 angstrom. Let us say it is an atom. Now this atom is moving, let us suppose. Now my question is, can we apply the same equation, that is Newtonian mechanics? So what is that Newtonian mechanics equation? X of t equal to x of 0 plus a half AT square. Shall I apply this? No. Why? Here what is happening? Oh, see. For example, whenever you have considered this microscopic, let us say an atom. Okay. Now here we are considering the probing. That means probing particle, just like a light, a radiation probe. This is nothing but a radiation probe. Don't write while I am explaining. Please listen. Radiation probe. So what will happen? Whenever an atom is there and you are sending some light, and this atom will absorb the light. How do you know that?
We cannot see the atom. We cannot see the atom, so that it's maybe absorbed and transmitted.
If you are unable to see the atom, how can you say that atom is absorbing light? I am asking one question. How do you know that atom is absorbing the energy, absorbing the light energy? Anybody? Okay. Is it a black body? Say yes or no? Is it a black body? Orange and orange body ఏంటి? మీరు కాంపిటీషన్ నన్ను కూడా బ్లాక్ బాడీ అంటారు, ఎందుకంటే బ్లాక్ కలర్లో ఉన్నాను. Black body means the body which is in black color is not black body. Listen. All the bodies are black bodies, but not perfect bodies, perfect black bodies. So no doubt this is the black body. Okay. So what is the meaning of black body? Which absorbs wavelengths. Which absorbs all wavelengths and emits wavelengths when on heating. Because whenever you have a black body, it will absorb automatically. But whenever you just stand before the black body, emit, it won't emit. It won't emit. When it will emit, whenever you have increased the temperature, then only it will emit the radiation. Now the question is, I ask one question here. How do you know that atoms are absorbing the radiation? Then in the interviews, what you have to say? Sir, if I consider the black body means it can absorb all the wavelengths. But whenever we heat it, that means temperature is increased, it is emitting the radiation. Without absorbing, how it will emit? I hope you understand the point. If it is emitting now, means already it is absorbed. So, from the study of black body radiation, you confirm that atoms are absorbing this radiation. That's why here we cannot neglect that radiation probe effect on the atoms. Is that clear? Yes. One minute. So here we cannot neglect the radiation probe effect. The radiation probe effect on this on the atom. So atom means especially what is this? It's a microscopic body. Microscopic body or system, whatever it is. Sir, how do you know that is absorbing means? You can say from the study of black body radiation. From the study of black body radiation. Black body means which can absorb all wavelengths and which can emit the wavelengths only on heating. Without heating, no black body will emit. Although you 100 times request, it won't emit even one time also. Once you increase the temperature, then only it will emit. Generally, whenever we ask the definition of black body, you will say like this: which can absorb and which can emit. Which can absorb automatically by itself, but which cannot emit by itself. You should increase the temperature. Got it? Okay, come on, first write down. Please participate in the discussion. Please listen carefully. And if you have any doubt, please ask. One thing please remember, you are M.Sc students, postgraduate students. So whenever you are asking a doubt, it should be in that level. But those who have not attended the bridge course, you better to attend as early as possible. We have given all the basic concepts of mathematics and physics in the bridge course. All we have explained, vectors, Newton's laws, everything we explained in the bridge course. Right. So now let us see how this quantum mechanics journey started. So one thing from this discussion you understand, at the macroscopic level, whether you consider the light effect or not, there will be no change in the motion of the body. There will be no change in the results experimentally whatever you are finding. But at the microscopic level, definitely you must consider the radiation probe effect, because from the study of black body radiation, it's very clear. Right. Ready? Right. Okay, fine. So let us see the journey from classical to quantum. Right. The first breakthrough in 1900. What happened? Max Planck quantum theory of radiation. This is quantum theory of radiation. This is by Max Planck. Right. So what is this? Quantum theory of radiation. Anybody knows? So for example, let us say this is what? Matter. Okay. Now this is what? Light. The light is falling on the matter. So just a few minutes back what we have discussed is, at microscopic level, we can't neglect the absorption of light. Say yes or no? Yes. Now I have taken some matter. Matter consists of molecules. Molecules consist of atoms. Good. Now let us suppose this light is falling on the matter. Then what this matter is doing? It is absorbing the radiation. How it is absorbing? It is absorbing in the integral multiples of h in. That is nothing but quantum theory of radiation. Quanta means a particular amount. Quantum numbers, particular numbers. Quanta means a particular amount. Okay, once again. So according to this quantum theory of radiation, whenever you have a matter, this is the matter, and here you are sending this probe, that means wave. Which wave ma? Electromagnetic wave. Just like a light, it's nothing but electromagnetic wave. And according to Planck's theory, it can absorb the radiation in the integral multiples of h. That's it. Okay, fine. Good. That's it. So whatever the amount of energy absorbed, this is nothing but what? NH. We'll derive this, don't get tension. And after that, 1905, another breakthrough. But just I am explaining some history. Maybe it will be useful to teach for your students after 5 or 10 years. Okay, ready. So I am not saying to children, your children, I am saying to students. Right. And 1905, what happened? Einstein. Photoelectric effect. Can anybody tell me what is this photoelectric effect? What it indicates? What behavior? Particle behavior. Excellent. It confirms the particle behavior of what? Light. Okay. So that we will discuss clearly. Okay, don't get tension. Just like this. This is the metal plate and work function. I will tell you all the things. Don't get tension. This is the radiation h nu, and what are ejected? Electrons. Electrons ejected with some kinetic energy. Okay, good. And after that, 1911 or 1913, what happened? Bohr's model of a hydrogen atom. According to this Bohr's model, Mr. Max Planck and what Max Planck said? Absorb the radiation in the integral multiples of h. What Bohr said? Mr. Planck, not only absorption, emission also integral multiples of h. Okay, fine. Bohr, that means let us say here we have an electron and it is absorbing energy and it is excited, and within few seconds again it is coming to the ground state by emitting. Whether it is absorption or whether it is emission, this delta E should be integral multiple of h. So the Bohr's model also confirmed whether absorption or emission takes place, it should be always in the integral multiples of h. Good. And after that, 1923, this is the revolutionary change, de Broglie dual nature. De Broglie dual nature of matter. So what de Broglie said? Mr. Planck and Einstein and Bohr, you are talking about what? Dual nature of radiation. Because all these things are talking about what? Particle behavior of light. Then de Broglie said, not only light, matter also behaves like a wave. That means this de Broglie dual nature means what? It indicates the wave, matter also have wave nature, wave-like behavior. Okay. In 1927, he got the Nobel Prize. And this was confirmed by Davison and Germer experiment. Davison and Germer in 1927. Then he was awarded the Nobel Prize. He was the student of Heisenberg. Who? De Broglie. De Broglie was the student of Heisenberg. Heisenberg was the student of Rutherford. Einstein got Rutherford. All these are German scientists. Okay, that's it. So this is the brief small history. That means this was started in 1900. So up to 1900 people thought there is only one physics. What is that? Classical physics. But unfortunately what happened? It can explain only macroscopic phenomena. It could not explain microscopic phenomena. So then finally these great people contributed something, and they have shown a way, and they have given a path to construct or to build the new mechanics, which is a quantum mechanics, which can explain each and every phenomena in microscopic world. The only one mechanics which can explain the microscopic phenomena is quantum mechanics. No other mechanics. That's why it is. I think here no doubt, because this is the history only. Those who are having basic doubts, please complete the bridge course. Right. The now onwards, listen carefully, very, very crucial. white color box this. Right, ready? Right. So finally what we understand is, in the microscopic world, our classical mechanics, which is not applicable at this in the microscopic world. So we are going to design a new mechanics called quantum mechanics, which can explain each and every phenomena in a microscopic world. Am I right? Right. Now let us see. Quantum mechanics. Babu, very important, listen carefully. All the things, whatever I am explaining, listen carefully. After that, please ask any doubt is there. Right, quantum mechanics. What is this? This can explain each and every phenomenon in microscopic world. Okay, good. Now here, the first we are going to start with this first one, of photoelectric effect. Photoelectric effect and Compton effect. Maybe today we will complete this photoelectric effect and tomorrow we will go to this. Listen carefully. Compton effect. Right. So before going to start this photoelectric effect, I have to introduce the types of particles. Sir, what is this types of particles? Generally, whenever you are studying any mechanics, always you will use the word consider a particle. Say yes or no? Yes. Every problem starts with consider a particle. What particle it is? How many types of particles you have? Let us see. So now, first one, particle. Anybody knows how many types of particles you have? Two. Free particle and bound particle. This is based on interaction. Based on interaction. Please say, otherwise you will forget. Now I am classifying the particle based on interaction. Now tell me. Now let us consider these two particles. They are sitting side by side. Are they interacting? They are interacting. Gravitational interaction is there. Interaction means not talking. That interaction is different. That will be nowadays everything virtual interaction. I am asking about the real interaction. Not understood. Okay. So whenever you have considered a student in this classroom, he is interacting with each and every student of this classroom. Through which interaction? Gravitational interaction. So that person is a free particle? No. So free particle means what? Who is not interacting with anyone. Hermite. You know what is the meaning of hermite? Hermite means a person who is not interacting with anyone. Isolated. That person is called a hermite person. So if you have a particle which is not interacting with anyone, so that kind of particle is what? Free. Free means what? It is not interacting with anyone. I am a free bird. What is the meaning of free bird? I need not to answer anyone. Why? I am not interacting with anyone. Then who will ask you the questions? Understand? Okay. Are you free particle? No, I will ask questions. Right. Particle. First one. Based on interaction. The first one is a free particle. It's very interesting. Please listen carefully, please. So just now I told you what is meant by free particle. Free particle means interaction is zero. That means potential energy is zero. No interaction. No interaction. Sir, if potential energy is zero, Then the total energy is nothing but what? Super, because potential energy is good. What is the kinetic energy? Super. So now this is the mass. Okay, let us say it is not interacting with anyone. It is a free. Now I am throwing this with some velocity. Can you please tell me what is the range of this kinetic energy? One more time I am asking. Listen carefully. Maybe actually you transform from one world to another world. Actually till yesterday your world is different. Okay. Now suddenly you came to the class and sitting on the benches. So still some people are still somewhere else. Please come back. Please come back. Okay. Listen. Listen carefully what I am saying. All these things they will ask in the interviews also. Please. So now what happens? Let us say this is the free particle. Means potential energy is 0. Now I am throwing this. Can you please tell me what is the momentum range or kinetic energy range? Any momentum it can have, na? 0 momentum it can have, and any momentum can have. Am I right? That means it is having from 0 to all the values. But if it is interacting with someone, that means there exists what? Potential energy. That potential energy is restricting the total energy. Hey, you should not have that energy. Whenever potential energy enters, the particle cannot have all the energies. Best example, hydrogen atom. Hydrogen atom potential energy is there? Say yes or no? Yes. At least serious and say, okay. So hydrogen atom potential energy is there? Yes. Because electron is interacting with the nuclear, the Coulombic potential. Wait. What is the ground state energy? Minus 13.6. First excited state energy? Minus 3.4. Minus 13.6 to minus 3.4. Do you have any other energy? What makes like this? That means what is making like this? That means there is no energy exists between minus 13.6 to minus 3.4. Potential energy. Potential energy restrict the system. Hey, you should not have this energy. Hey, you should not have this energy. If there is no interaction, all energy is ours. All energies it can have. Understand? Yes. 1 second. So this momentum range is from where to where? Infinity means not a number. It's a big number or something like that. Okay, don't think it is infinite is a number or something. That's why energy is also from where to where? That means all energies are only particular energies. All energies. Whenever you have all energies, is it a continuous spectrum or a discrete spectrum? That's good. Now tell me, free particle spectrum is? That's good. So whenever you said it's a free particle, means what? It is not interacting with anyone, anything. Its a potential energy is, and it is having only kinetic energy. That's why energy range is from all energies. That's why the spectrum is free particle energy spectrum is. Now come to this. The next particle is bound particle. Babu, last Babu. See the board. Don't write while I am explaining. Bound particle. Right. In this case, the potential energy is not equal to 0. That means there exists interaction. So best example I will take. So this is the nucleus and here is an electron. The electron is revolving around the nucleus and the potential energy V of R is equal to minus ZE square by 4 pi epsilon naught R. That is the Coulombic potential energy. Then the energy, if you see, same kinetic energy plus this potential energy. Anybody knows what is the total energy of the hydrogen atom? Very nice, very nice. Minus ZE square by 8 pi epsilon naught. Half of this potential energy. Whatever you have written potential energy, half of that is the total energy. Good. Okay, sir, this negative indicates what? The negative sign indicates what? Bound. Bound system. Repeat. Bound system. Good. All bound systems energies are negative. Can you please tell me? Can you please give one example? A bound system in your daily life. Have you seen? Okay. How you will send the satellite? In which path it will move? Circular, parabola, hyperbola, elliptical? Huh? Elliptical. Okay. I will ask one more question. You know Bohr's model? Rutherford model, Bohr's model. Rutherford model, Bohr's model, which orbits? Circular orbit. Sommerfeld model, which orbits? Elliptical orbits. Why don't you have parabolic orbits and hyperbolic orbits? Do you have any parabolic orbits? Hyperbolic orbits? They are not bound systems. The energy of a parabolic system is not negative. The energy of a particle moving in the hyperbolic path is not negative. The energy of the particle moving in a circular path and elliptical path is negative. That's why those are closed orbits, which are stable orbits. But hyperbola and parabola, the energy is not negative and the system is not bound. That's why orbits are not closed. Okay, cool. So it's a bound system, no doubt. And if you see, this is the ground state energy. How much? Minus 13.6 eV. And this one? So do you have any energy between this? No. There exists no energy. No energy exists between this. That means what? Only particular energies are allowed. Only particular values are allowed. That's why this spectrum is a discrete or continuous. That's good. Now this is the difference between a free particle and a bound particle. A free particle means potential energy 0 on the spectrum is. A bound particle means potential energy not equal to 0 on the spectrum is. Whenever the particle is interacting with something, any potential, it cannot have all the energies. It can have only particular amount of energies. That's why the energy spectrum is discrete. You understand these 2 points? Please ask any doubt in this context. Any doubt? Calicut, Pune, please ask. If you listen carefully, you won't get a doubt. Please listen carefully. And don't write while I am explaining. బ్రేక్ అయిపోతున్నాయి. చాలే ఇది ఎక్కడ మన Yes, ma'am.
What does it mean when a particle is a free particle, sir? That means when an electron is a free electron, whatever, whatever it can, it means it can absorb any wavelengths of light or.
Again ask. Yeah,
So,
please ask.
What does it mean when a particle is a free particle? Like when an electron is a free electron, whatever light we shine on it, it will absorb everything. Does it mean like that, or what does it mean like it takes all energy values at particular point? What will be the energy? If
Right. So good question. Just wait. Sit down. Please listen the next discussion. Her question is, what is this a free particle? If I say free electron, what does it mean exactly? And she asked one more thing. If I say free electron, so what it will do whenever it is it absorbing the energy or not? That means, is it absorbing the complete energy or not? This is what you are asking. You will get the answer while I am explaining photoelectric effect and Compton effect. Listen carefully. Understand her question? She is asking a free particle. You said free particle. Is it over? So you are describing the free particle. So what exactly free particle physically? So it will absorb the energy or not? That means now you have a free particle and you are sending some energy. So will it absorb the completely or not? Or it will absorb only partially, or will it absorb a complete energy? This is what she is asking. Anybody knows? A free particle cannot absorb the energy completely. Just wait, I will discuss. Is it over? Right. Okay, so now before going to start this photoelectric effect and Compton effect, one more thing we have to describe. This is photon. I hope you know this is the quanta of radiation energy. Okay, so everybody know what is the energy of the photon? Come on, say E equal to h nu or h cross omega. Say yes or no? Yes. Now whenever you have a photon of a frequency nu or omega, this is the frequency and this is the angular frequency. For this it is the hertz, and for this radian per second, but we won't mention the radian, you can say simply second inverse. Okay, right. And the energy, just now I told you how much? H nu. This can be written as H. This is the frequency. Frequency is nothing but what? C by lambda. So energy of every photon equal to how much? C by lambda. Wait a minute. Now here you have Planck's constant. Come on, say 6.62 into 10 to the power of minus 34 joule second. And H cut or H cross 1.05 into 10 to the power of minus 34. This is nothing but h by 2 pi. You must remember these values while you are doing the problem. Okay, good. Now ready. So this is the energy of the photon. H value, C value, if you substitute, you will get 12,400 by lambda. This is the units electron volts, lambda in angstrom. Sometimes while you are doing the problem, they will give wavelength in terms of nanometers. In terms of nanometer. Listen. Nanometers. Then you should not take 12,400. What you have to take? 1240. Please remember, you will save so much time. Because if you are using this formula, what we have to do? You have to convert that nanometers to angstroms. While before you convert, next CSR notification will come. So that's why better to remember this. Okay. In terms of nanometers, 1240 by lambda in nano. Whenever lambda is given in nanometers, what you have to use? Lambda in angstroms. 12,400, and this is also electron. Now let us take a visible light. So small example. Visible light wavelength range is from where to where? Nearly 4,000 angstroms to 7,000. 4,000 to 7,000, that is the range. 4,000 to 7,000. So that's why if you see the energy, so this is I have given in angstroms. That's why 12,400 by 4,000 to 12,400 by 7,000. This is in terms of electron. This is around 3.1 eV to 1.7 eV. If anybody asks what is the range of energy spectrum of visible light, from where to where? More wavelength, less energy, less wavelength, more. Violet to red, with GR, violet to red. Clear? Good. So this is a small example how to calculate the energy of the photon. So energy of the photon is given by 12,400 by lambda in angstroms, or 1240 by lambda in. If you are not saying, you won't remember. You won't remember. You have to say, otherwise you won't remember. Do you know how you learn mother tongue? No. Listening and reproducing. Speaking radu. Speaking radu manaki. We don't know how to speak first. We know only listening and reproducing. That's it. Now your mother tongue is physics. No, what I'm saying is 9 papers, around 3,000 concepts you have to remember. 3,000 formula, 3,000 concepts you have to remember. Otherwise you can't go to the exam also. Today one student made a call and asked, do you have any crash course for September CSR? No, we will become crash. That's why we are not having any crash course. For me 6 months is also not sufficient actually. To explain each and everything, 6 months is also not sufficient. How we will complete the 2 months? It's a cheating only. So no use. So that's why please forget your past. Okay, now onwards please involve in the class and repeatedly say, otherwise you won't remember. It's impossible. Okay, that's good. So right, whenever I ask you, please say Babu, don't neglect. That's it. This is the energy of the visible light range. Okay, good. Yeah, come on, write down. Anybody knows the properties? Rest mass. Yeah, 0, very good. Good. So rest mass is 0, that's why E equal to Pc. Why the photon is having energy E is equal to Pc? Because its rest mass is 0. See this formula, maybe you will remember from your BSc. So the photon energy E equal to h nu or hc by lambda, that is a 12,400 by lambda in angstroms or 1240 by lambda in nanometers. First, please learn the subject properly and you can write any number of exams. So you are getting ready for the December CSIR, not for this September CSIR. Please remember. Any doubt, ma? Yeah. Rest mass. E naught is called rest mass. E naught is the rest mass. This is the energy relation. I hope you know. Relativistic particle energy relation E equal to under root P square C square plus E naught square. For a photon, rest mass is what? Babu, in this, whatever you didn't understand, please ask me again. Okay? So I thought that you know already. If you don't know, please ask. Rest mass is a 0. That's why E naught is a 0. That's why E equal to what? PC. E equal to PC is valid for not only for photon, any particle whose rest mass is 0. Any particle. So if anybody asks E equal to PC is valid only for photon, no. It is valid for any particle whose rest mass is 0. Good. Now ready. Now listen. This is a very important discussion. Actually, this is from B.Sc. I don't know how many of you learned in B.Sc. Listen, please. Photoelectric effect versus Compton effect. Who will win? Huh? We will win. Alright. Photoelectric effect and Compton effect. So what is this photoelectric effect? First, let me explain, Babu. Please listen. Now, whenever you have a metal, this is the metal plate, let us suppose. Now here I am sending some light here. The light of certain frequency. Why I said certain frequency? If I didn't use that certain frequency, you won't get any electron, because every metal is having one thing called work function. The minimum energy required to bring the electron out. Am I right? You studied in B.Sc. Good. Now listen. Here I have a metal plate. This metal plate is listen carefully, please. Here we have an electron. So many electrons are there. And this metal plate is having a work function. This is called work function. Work function means minimum energy required to remove the electron. Okay, now I am sending a light of certain frequency. Could you please tell me how much energy you are sending? Then this energy is absorbed by the electron, and here we are getting this electron out. That means this electron is getting some kinetic energy. If you see carefully, in the photoelectric effect, they will write it as Ke max. That is the maximum possible kinetic energy. More than that, not possible. Then what is the minimum, sir? 0. Minimum is what? 0. Maximum is what? Whatever we are going to write here. So I hope everybody know how much you are sending, how much you are spending. Spending 5. How much you are getting? Getting equal to spending. Sorry, sending H in spending 5. That's it. So what does it mean? This is the law of conservation of energy. The photoelectric effect equation is nothing but what? Law of conservation of energy. Whatever you are sending, it is utilized in two ways. One is the work function, another is the kinetic energy. That's why H nu equal to kinetic energy plus phi, or kinetic energy equal to H nu minus phi. Good. Wait a minute. And this can be written as a half m velocity max square equal to H nu minus phi. Sometimes we will write this H nu as Hc by lambda. Yes, phi. That's it. Okay, cool. This is about photoelectric effect. Now come to the Compton effect. In Compton effect also, I have this metal plate again. Okay. So here I am sending some photons, X-ray photons or something. Then what is happening? See. Here is an electron, just quite similar to this. Here also electron we have. And I am sending this X-ray beam. These are the X-ray beam, and what will happen? This X-ray beam will be scattered like this. I said scattered, and this electron will be recoiled. Recoiled. This is the original direction. From the original direction you have this phi, and this is what now? Theta. And this is the electron. This electron is recoiled, and the photon is, and this is the incident. Okay. So I am using the word scattered photon. Shall I use the word scattered electron? You are using two words, scattered photon, recoiled electron. Shall I reverse these words? Shall I say recoiled photon? Shall I say scattered electron? Why? Why you are saying a scattered photon? Why you are saying a recoiled electron? Now let us say here is one person standing. Okay. Now I am at rest. Now one person is running from that side. He is moving, and he is moving towards me. Are you listening? Where are you? In Hyderabad, huh? Okay. Right. So I am standing here. One person is running and coming towards me, and hit. Earlier I am in which position? Rest. I am in which state? Rest. Once that person collide with me, then what I will do? I will do like this now. That is called recoiled. The particle which is already at rest, that is said to be recoiled. The particle which is already in motion is said to be scattered. Your photon is moving, that's why it is scattered. Your electron is at rest, that's why it is recoiled. That means what exists there? Collision exists. After the collision, the particle which is moving, if it is earlier at rest, we have to say recoiled. We should not say scattered. So these are technical words. Okay, good. Okay, fine. And now this is the energy H nu. And this energy is what ma? H nu prime. And this is a hc by lambda. And this is a hc by, no, wait. Whenever I ask, please tell, otherwise just listen. hc by lambda prime. And this is the energy of the electron. Simple here also. And this is the energy you are sending. And here what happened? Come on, say h nu equal to h nu prime plus energy of electron. Okay. So what is the difference between these two? What you are observing in the diagram, please tell me. In photoelectric effect and Compton effect, just observe carefully. And what is the difference you are observing? Here electron is there? Yes. Here electron is there? No difference. Here incident photon? Yes. Here incident photon? Yes. Yes. Here scattered photon? Yes. Here any scattered photon? No. Oh. In photoelectric effect there is no? There is no secondary photon. Say yes or no? Yes. Okay. Wait. Here there is no secondary photon. If anybody asks what is the difference, you have to say this. In photoelectric effect there is no secondary photon. In Compton effect, there exists a secondary photon. Why? Why here we don't have secondary photon? Why here you have secondary photon? Anybody?
Their energy is completely absorbed, and in that case energy is not completely absorbed.
So what she is saying is, here the energy whatever you are sending is completely absorbed by the electron. Whatever you are sending the energy, it is not completely absorbed by this electron. So what is the difference? Means, see, this electron is a bound electron. Repeat. And this electron is the free electron. Earlier she asked one doubt. Free electron means what? Just like that, whenever you are sending some energy, if it is not absorbing energy completely, then what you are saying? A free electron. And if it is absorbing the energy completely, bound electron. So a bound electron can absorb the energy. A free electron cannot absorb the energy. You are sending some energy, it is not absorbing completely. I want this much only, I don't want the remaining thing. A remaining thing is again emitted. But this one, that means it is taking completely. So what kind of electron it is? What kind of electron it is? Just to go back to a few minutes back. Go back to a few minutes. Sir explained a free particle and a bound particle. What free particle means? Potential energy. Bound particle means? That means in this potential energy is not zero. In this potential energy is zero. No. This is the material. You have potential. You have interaction. Every electron is interacting with the adjacent ion core. Okay? So, understand what I am saying? So, both metals only. Here also you are taking a metal plate and here also you are taking a metal plate. But here you are saying the electron is bound and here you are saying the electron is free. Whatever the definitions earlier we have given, those are not the definitions here. Free and bound depends upon the context what you are discussing. The earlier what we have discussed, I told you clearly written, based on interaction. Here free and bound are both are different. Sir, what is this here? What is this a free particle and what is this bound particle here? I don't know how many of you know this. Listen carefully, please. Everyone, observe the board. So here you got it out. What is this a free electron and what is this a bound electron? Listen. For example, here I have an atom. Oh, listen please. This is the nucleus. Okay. And this is the K shell. And this is the L shell. And this is the M shell, like this. I hope everybody know. How many K shell electrons? 2. L 8, 8, 6 gadamma. 2, 8, 18, 32. 2n square. Thanks. 1, 2, 3, 4, 5, 6, 7, 8 somewhere. Listen carefully. Now again here also I am taking the nucleus, and this is the K shell, L shell and M shell, something like this. Six, 7, 8, something like this. Observe carefully, please. Now here I am talking about what is meant by free and what is meant by bound in this photoelectric effect and Compton effect. Maybe in textbooks they have written electron in photoelectric effect. Electron is treated as, and in Compton effect electron is treated as. Why it is treated like that? Listen carefully. Actually what will happen whenever you have a metal plate and you are sending the light, you have valence electrons, yes or no? Yes. K shell electron, L shell electron, M, N, something like that. Okay. Now whenever, all of you listen please, whenever you are sending this light like this, okay, so this is the energy what you are sending, H nu. H nu are the energy you are sending here, okay, and it is interacting with this innermost electron. Are you understanding what I am saying? Yes. I use the word innermost electron. Every innermost electron is a tightly bound or loosely bound? Tightly bound. That's why it is a bound electron. Oh, photoelectric effect is observed when that incident photon is interacting with. That's it. The innermost electron is tightly bound to the nucleus or tightly bound to the system. Here the word bound electron means it is tightly bound or innermost electron. 1 second. Now here I have one electron. What is this? Outermost electron. Say yes or no? Yes, sir. So whenever you are sending energy, I don't know how many of you know this difference. Listen carefully. If you don't know, please listen. If you are sending this energy, you are sending some X-ray beam or photon, whatever it is. Now it is interacting with which electron? Outermost electron. Outermost electron is loosely bound or tightly bound? Loosely bound. So common sense. In the metal, how you will be having a free particle? In the metal, the electron, every electron is bounded. Bounded means it is interacting. Say yes or no? Yes, sir. But here they are using the word free means loosely bound. That's why they are using the word free electron or a free particle. So this X-ray beam or whatever you are sending, it will go and interact with the outermost electron. Then which effect you will get? And whenever this incident photon interact with the innermost, what you will get? So this is a tightly bound. It won't come. It's rigidly fixed. So that's why you have to send the complete energy. You have sent some energy and it will absorb the energy completely and it will go. It is easy disturbed. If you slightly send some energy, it will take some energy and it will. Right. But free electron cannot absorb the energy completely. A bound electron. So I hope you got this point. This is the innermost. And not exactly here, just I have drawn the diagram. I can't draw all the electrons now. I have to take lead 82. If I draw the diagram, class will be over. Okay. So just I am drawing here. It's not exactly near to the nucleus, somewhere else. Innermost. So innermost means what? Tightly bound. That's why this electron is nothing but or is treated as which particle? And this electron is loosely bound, it is treated as. So if the X-ray beam or any light is interacting with the innermost, that electron is tightly bound. it will absorb the energy completely, and that effect is, if the beam whatever you are sending, light beam whatever you are sending, it is interacting with the outermost electron which is loosely bound. That's why it will take the energy partially and it will emit the remaining energy again as a secondary photon. That effect is. So you understand? So I hope everybody understand why the photoelectric effect electron is a bound electron, why the Compton effect electron is same material, same energy you are sending, but you are saying once electron is free, once you are saying bound. That means that photon can interact with any of the electron, either innermost or outermost. So it depends upon the completely structure where it is interacting. So that's why this is a tightly bound and this is a loosely bound. Here free means what? Loosely bound. That's why it will accept only partial energy. It is a tightly bound, that's why it will accept a complete energy. Is that clear? 1 minute. Yes.
So what factors the metal decides it should be photoelectric effect or Compton?
Metal won't decide, whatever you are sending that energy. Because for visible light you will get the photoelectric effect. Whatever solar panels you have, that is which light? The visible light only. In the visible region also you will get that photoelectric effect. But X-rays, Compton effect is a prominent only for X-rays. For visible light you won't get the Compton effect, because that energy is not sufficient. X-ray means having more energy than the visible, because X-ray wavelength is what? 1 angstrom to 10 angstrom. Visible is what? 4000 to 7000. So what will decide means same material, but the probing photon, whatever you are sending, that will decide whether photoelectric effect exists or Compton effect exists.
Sir, usually in visible light we get photoelectric effect.
Yes, yes.
So innermost electron only we are removing. So we need
He-
more energy for it. No, sir?
Once again, actually that innermost electrons means conduction electrons. Conduction electrons in the metal are free electrons.
Yes, sir.
Okay, but here don't think it is a free again, or you are saying a bound. Here bound means in sense it is a tightly bound to the nucleus or somewhere else, innermost electron like that. But it is a conduction electron. It's a conduction electron.
Conduction electron will be outermost. No, sir.
Conduction. That total thing I am talking about the valence band only.
Okay, sir.
I am not talking about the conduction band or valence band. All the electrons are valence electrons only. I didn't draw the complete diagram, okay. Just I have said it's a inner one and outer one, something like that.
Then if we take a normal metal plate and shine a X-ray, then both photoelectric.
No, both you can't observe. Any one thing is chance. Any one thing you will observe. But X-rays if you use, you will observe Compton effect.
Yes, sir.
X-rays.
That X-rays can also remove an electron. No, so photoelectric effect also can be possible because of that X-rays. No, sir.
That we can't say that photoelectric effect. If the secondary photon exists, we cannot say photoelectric effect. You have to say Compton effect. Although what you are saying is, so electron is coming now, why don't you call it as a photoelectric effect? No. Einstein won't accept. Okay. So if a photon is if a photon is not there, then we have to say photoelectric effect. Otherwise, you have to say Compton effect. That's it. Both the cases electron is coming out. The only difference is, in first case it is absorbing the energy completely, and the second case it is not absorbing the energy completely. That's it. That is the only one difference. Yes. Her query is, in both the cases electron is coming out, why don't you call Compton effect as a photoelectric effect? No, we cannot say like that. So if the secondary photon exists, we have to say it as a Compton effect, and if the secondary photon does not exist, we have to say photoelectric effect.
Sir, actually that was not my question. Sir.
Mm.
I asked in a metal plate there will be so many atoms, right? And there will be so many X-rays coming. So one X-ray will be interacting with the valence.
We don't know which electron, which X-ray photon will interact with which electron, we don't know. It's a statistical process.
It may interact with valence also, it may interact
anything.
So both photoelectric and Crompton will be possible in the same metal.
More prominent we will observe. Experimentally, generally what will happen, the thing which is a prominent we will observe. So that's why if you are sending X-ray, you will always observe the Compton effect. If you are sending a visible light or a UV light, then you will observe photoelectric effect, more prominent.
But both will be possible.
Possible. Why not? Same metal. Prominent means, see, this is the material, this is the matter. Okay, if you throw this, what nature you are observing? Particle nature. But it is having wave nature also. But it is not prominent. Like that, although Compton effect is there, but you won't observe because it is not prominent. It is a prominent only for higher energy beam, that is X-ray beam. Photoelectric effect is a prominent for lower energies, visible and UV rays. That's it. Any doubt, please ask. Of online centers, please ask any doubt. You please write properly. It's a bound electron can absorb, you should write this, can absorb the energy completely. And this free electron, please write, this free electron cannot absorb the energy completely. We have already given the two different definitions for free and bound. Earlier we said a free particle means potential energy is 0, bound particle means potential energy not equal to 0. But here we are saying something different. A bound electron can absorb the energy completely. A free electron cannot absorb the energy completely. That's why we have a secondary photon, and that's why here there is no secondary photon, because the energy is completely absorbed. Here the energy partially absorbed. That's why you have secondary photon. Let us do some applications on photoelectric effect. Write some points. First point, photoelectric effect. Just again put the subheading, PEE, photoelectric effect. Is it over? Right down. First one, photoelectric effect. First point. This is instantaneous process. First point. This is instantaneous process. Instantaneous process. Second one. Second. Photoelectric effect. First point, it is an instantaneous process. It is an instantaneous process. Second point, there exist means you can write like this. This is the symbol for there exist. There exist a threshold frequency. There exist a threshold frequency below which the photoelectric effect cannot take place, below which photoelectric effect cannot take place. Next one. Kinetic energy of the electron, kinetic energy of the emitted electron, put a star mark at the third point. Kinetic energy of emitted electron is independent of intensity of the light, is independent of intensity of incident light, is independent of intensity of incident light. That means you have used some intensity and you got some kinetic energy of the electron, okay, and you increase the intensity, again you have same kinetic energy, okay, kinetic energy won't be changed, understand? Then what will change, sir? Number of electrons will increase. Number of electrons increased means a photoelectric current is increased. So if you increase the intensity of the incident light, kinetic energy of the electron won't be affected, only number of electrons emitted is increasing, that's why current will be increasing. Is it clear? Good. Right. Now let us take a few problems, Babu. First one, write down. Listen. Oh, okay, 1 minute, listen. Babu, listen please. Photoelectric effect, 1 minute. So what you are saying is, here this is the metal plate, work function is there, and you are sending the energy, what is that? H in. What you are sending? Electromagnetic wave. Say yes or no? Yes, sir. This electromagnetic wave contains electric field? Yes. Electric field as well as magnetic field. Definitely. So photon, light means what? EM wave, electromagnetic wave. It contains both electric and magnetic. Which field is helping you to see the objects? Then what magnetic field is doing? Both. Electric field will affect the retina. Electric field will affect the retina, magnetic field won't. Electric field is the reason or main reason for the sensation of vision, sense of vision or something. Listen. So here we have electric and magnetic fields, okay, and this is the electron emitted with some kinetic energy. What is the first one? Could you please tell me what is the equation? Ke max equal to h nu minus phi. Otherwise this is hc by lambda minus phi. Good. And you should remember hc value 12,400. Okay, not electron volts. Whenever you are using lambda in angstroms, then you have to just remember this. Right. Okay, so here I am using the electric field. Fine. Photon. Electric field is like this. Let us say electric field of the photon is E naught sine omega t. In the question, they will give this electric field E naught sine omega t. And what they will ask, what is the energy, what is the kinetic energy of the electron? This is the question. What they have given? Electric field of the photon. This is what? Electric field of photon. And work function also given. What they are asking? How you will find? Same equation. The kinetic energy of the maximum kinetic energy of the electron equal to what? H in. I have given earlier one more expression. Minus. You have to use this omega here. I am explaining how to handle the problems. Are you listening carefully? Yes. Good. This is the first model. Second model. Again they are giving the electric field of the photon, which is E naught sine, listen carefully please, E naught sine omega 1t plus sine omega 2t. Okay. So here they have given, this is the electric field of photon. Electric field of photon is given. And we have to find the kinetic energy of the electron. According to photoelectric effect equation, kinetic energy of the electron equal to, but how many omegas you have? Omega 1 and which omega I have to use? Higher omega. Why? You are finding maximum kinetic energy. What you are finding? Maximum. That's why this omega is always. For example, here I have given 4 into 10 to the power of 15. Here I have given 6 into 10 to the power of 15. Which one you have to use? I hope everyone understand. Yes. That's good. So one second. Always take. Babu, listen carefully, because while you are solving the problems, these are very, very useful. Always take a higher frequency. So one more example I am taking. They have given electric field like this. This was the JAM question, E naught. I think they have given some cos omega naught t plus sin omega naught t into cos omega t. This is the question they have given. Can anybody stand and say what you will take as this, what you will take this omega? Here for example you are saying omega 2 is greater than omega 1, then your omega should be. Now this is your question next. Can anybody tell me what is your omega now? Same formula, Ke max equal to H cross omega minus 1. Can anybody tell me what is this omega? Omega naught plus omega. You are not thinking, that's why you are not saying. If you think, you will get the answer. You are only half you are listening, half you are going. Your potential barrier is very less height. So please make it infinite. It will be trapped. Otherwise it will go again. You are not listening properly. So this is the question C. Cos omega naught t. Here what you have? Sin omega naught t, cos omega. Sin omega naught t, cos omega t. That means you are not seeing also properly. So here 2 is missing. That's why I can write 1 by 2 and 2. So this is a 2 sin A cos B. 2 sin A cos B is what? Sin A plus B plus sin A minus B. So what is the higher frequency? 3 frequencies are there. Omega naught plus omega, omega naught minus omega, another is omega naught. Out of all these, which is a higher one? Omega naught plus omega. I don't know how many of you understand this. This is sin omega naught plus omega t minus plus sin omega naught minus omega. So that's why this is the higher. So I hope everybody got this. And here omega equal to how much ma? Omega naught plus. Is that clear? Okay, come on, write down. Whenever they are asking a question on the photoelectric effect, this is the first model. The electric field is given. Just like this, electric field. electric field of what? Electric field of photon. Whenever electric field of photon is given, if you want to find the kinetic energy of the electron, always we have to choose the higher frequency of that electromagnetic wave. Don't forget this. Yes? Any doubt? One minute. Yes, Babu, please tell me.
Sir, practically, are there any free electron, like for real?
No.
No loosely bound?
No, practically a free electron is not there outside. That means whatever the outside free particle you are talking, that is the potential energy zero particle. Okay,
Sir,
so
in Compton effect, sir, what's the phi there?
no, phi won't be there. Phi won't be there. Compton effect, that's the difference now. Phi won't be there. There is no threshold energy. There is no minimum energy. Only the required is X-ray.
So, sorry, sir. I mean, in photoelectric effect, phi is there and it works as the work function, right?
Yeah, the minimum energy required to remove the electron.
Minimum energy required to remove one electron, sir.
Yes.
Compton effect, sir, the phi, the angle between the straight line and the scattered.
Oh, okay. So you are getting that doubt. Wait a minute. So 1 second, I understood. I think that's why in the textbooks they will write this as W. W for work function. Okay, don't be confused with this phi and that phi. That phi is the angle and this phi is what? Work function. If you are having a confusion, please write it as W. Yes, continue, Babu.
Is that phase shift or what, sir?
What is that? Phi?
Sir, in Compton effect, is that phase shift?
Compton effect? Repeat the question, please.
Sir, in Compton effect, sir,
Yeah.
that angle is phi, sir, right?
Yes, Babu.
Sir, thank you.
That phi is not the work function, that phi is the angle. If you are having a confusion, my humble request, in photoelectric effect, instead of a phi, you please take W. So I hope everybody understand the first point. Whenever they have given electric field, if you want to find the kinetic energy of the electron, which omega we have to use? Always we have to use higher omega. If only one omega is there is no issue. If you have two different omegas, always go for higher omega. Why higher omega you are taking means? You want maximum. If you want output maximum, you should use input as also maximum. That's it. And the second point is also very crucial. Stopping potential. Spelling S-T-O-P-I. Stopping potential. Oh, there is no space. Yeah, please, any doubt, please ask. Calicut, Pune, any doubt, please ask. We will explain Compton effect again tomorrow, not today. Today we are explaining only photoelectric.
We are taking half into 2 of that term, right? So there is one half in that energy term for that particular sign.
Half is outside now, sign outside.
So it doesn't affect.
Only omega is the coefficient of T. Omega is always a coefficient of T. Coefficient of x is k. Coefficient of t is omega. Still, please ask. Right, now listen. The next one, this is also very important for doing the problems. Listen, stopping potential. Stopping, spelling correct, Babu? Huh? Double P, correct? Why double P? Yeah, stopping potential. Listen. Sir, what is this stopping potential? Let me ask a question. Now this is a charged particle Q. Electron. Electron is a charged particle? Say yes or no? Yes. Now I want to accelerate this electron. What you will do? You will apply force. You will hit like this. You will apply potential. Say yes or no? Yes. Once you apply the potential V, then what is the energy it gains? QV. Where Q is the charge and V is the applied potential. An electron is there, I applied 10 volts. What is its kinetic energy? 10 eV. I applied 100 volts. What is the energy? 100 eV. Is it okay? Wait. Very important. Here again I have taken the photoelectric effect. Babu, here phi stands for work function. Work function. If you are having any confusion, you can take W also. But I prefer phi, that's it. And this is the incident energy h nu. And here is an electron. And you are getting some kinetic energy. This is the kinetic energy of the electron. The equation says kinetic energy max equal to how much? That's good. Okay. So you are sending some energy, okay, and the electron is absorbing that energy and electron is coming out with some kinetic energy. Say yes or no? Yes. I want to stop that electron. What electron you are stopping? You are going to stop the most energetic electron. Sir, why it is most energetic electron? Its kinetic energy is what? Max. Oh, second. I told you the electron is coming with the maximum energy and I would like to stop this. How? In a reverse. Earlier what you said, if this is an electron, if you want to accelerate it, what you are applying? Potential. Reverse. If you want to stop this, again apply potential. That potential is what? Stopping potential. Just like a negative potential. Stopping potential is the negative potential. The meaning of a negative potential is you are using that potential to stop the most energetic electron. Wait a minute. So I hope you understand the definition. Stopping potential is defined as Vs. The potential used to stop the most energetic electron. Oh, very simple. If I am moving with some kinetic energy K, if you want to stop me, how much potential you have to apply? I am an electron. Let us say I am an electron. I am an electron, I am moving with the kinetic energy K. If you want to stop me, how much potential you will apply? Forget about minus. How much potential you will apply? Vs. But how it will stop me? It will stop only when my kinetic energy equal to EVS. Say yes or no? Yes. Because if this is the electron, you applied Vs, then what is its kinetic energy? EVs. And that should be equal to my maximum kinetic energy, then only it will be stopped. If I am having some 100 joules energy, if you are applying 50 joules energy, you can't stop me. I hope you understand what I am saying. So in the same way, if you are stopping means what? The kinetic energy max should be equal to, forget about negative, it's a negative potential. And the graph also, it will be in the negative side. Oh, what is a kV max? What is a KE max? I think I can write EVS is equal to how much? So here is a small task. Now here I have one material with the work function phi1, okay, and I am sending the photon of energy h nu, and the electron is coming with kinetic energy k1, and I have another material with the work function phi2, but what I am doing is I am using the same energy, that is a h nu, and the electron will come out with some kinetic energy k2. Yes or no? Yes. Good. Now, if I want to stop this most energetic electron, I am using the stopping potential Vs1. Here I am using the stopping potential. Now from this, could you please tell me h nu minus phi1 equal to EVS1. For this second plate, h nu minus phi2 equal to EVS2. Is it okay? Yes. Okay. Now wait a minute. So observe carefully. If I take, one under the other, something like this. H nu minus phi1 equal to Vs1. I can subtract? Yes. Minus, plus, minus. These two gets cancelled. And this is nothing but phi1 minus phi2 equal to E. I am writing only V2. Is it okay? So, in your questions, they will give two materials. One material with work function phi1, another material with work function phi2. Then what is the relation between work function and stopping potentials? Work function and stopping potentials. Phi1 minus phi2 equal to E into, where this V2 minus V1, this is what? Stopping potential. And these are the work function. Okay, so this also very, very important task. Write down.
For the case of some sinusoidal or trigonometric energy function, what is the significance of the amplitude E0 in this whole process?
Yeah, so good question. What he's asking is, you have taken a sinusoidal wave, electric field equal to E naught sine omega t. You just already explained about omega. Which omega we have to take a higher frequency? And he's asking, I have increased the amplitude, what will happen? That means I have taken once amplitude is E naught, second I have taken amplitude 2 E naught. What will happen? Anybody? If amplitude is changed, what will happen? Intensity will be increased. Intensity is a proportional to square of the amplitude. If intensity is increased, what will happen? Kinetic energy won't be changed. What will be changed? That's good. If you want, you can draw this diagram also. For example, you have like this. This is the number of electrons and this is the potential. And here I am using one intensity. Okay. And here I am using another intensity. But the stopping potential is same. Why stopping potential is same? Kinetic energy is the same. That's why stopping potential never change. Understand? This was the 2020 JAM question. For stopping potential won't be changed if you change the intensity. This is the intensity 1 and the intensity 2 or power. Sir, how power and intensities are related? Intensity equal to power by area. So if you increase the power or increase the intensity, there won't be change in the stopping potential because the kinetic energy remains same. Please write that. Kinetic energy, already written I think somewhere. Kinetic energy of electron won't be changed if intensity or power is increased. All these things are in the B.Sc. If you are having a doubt, please read any B.Sc book, Modern Physics.